One of the key principles to architecting highly available applications is to eliminate single points of failure. And most of the AWS managed services use multiple resources across at least two availability zones to ensure that systems can sustain a data center outage. So when you're architecting your own highly available design, you should follow this same process. So let's start off by looking at a common architectural pattern for building a highly available internet-facing web application. So to start off, we'll create an Amazon VPC or a virtual private cloud. This is the networking component, and remember that VPCs can span multiple availability zones, and in this model, we'll be using two, so we can have two of every single resource. And along with this design, we'll have private IP subnets in each availability zone. And remember that availability zones are basically separate, distinct physical locations within the same region. Now, when you deploy resources into a private subnet, it means that they don't have a direct route to the internet. And this is a common approach to make sure that your workloads aren't accessible from users coming in from the internet. So the idea here is that along with your private subnets, you'll also have public subnets for internet-facing workloads like proxy servers or elastic load balancers. And you'll end up with a public-private subnet pair in each availability zone. Now, to allow outbound access to the internet from your private subnets, you can provision a NAT gateway in each public subnet. And then the default route to the internet for the resources in the private subnets would go through the NAT gateways and their associated availability zone. So the NAT gateway is a new service from AWS, and in the past we actually had to build these servers up manually ourselves, but now you can simply provision a NAT gateway. You don't have to worry about scaling it or making sure that it's highly available. And of course, outbound internet access is important for servers fetching updates and talking to AWS services outside the VPC, but we also have to think about letting users from the outside world access our web application. So let's talk a little bit about that. One common approach is to deploy your web front-end servers in two availability zones. They're load balanced by an elastic load balancer. In this scenario, the ELB would be deployed as an internet-facing load balancer with an ARM in each public subnet. So the ELB would be able to route connections from the internet to the web servers in the private subnets. And keep in mind here that the ELB spans two availability zones. So not only are we getting load distribution in this model, but we'll also be able to keep the application online if one of the servers fails or if an entire availability zone goes down. In addition to web servers, we might also have other back-end components like an application server or a web service API. And again, we'd want to make this service redundant by deploying at least two of those servers, one within each availability zone. And for the database here, we basically do the same thing. We'd have at least one database server instance in each availability zone, and we could replicate database content from one node to the other. And the system can automatically fail the active database instance over to a passive server in the event of a failure. And this is basically the idea behind Amazon RDS multi-AZ deployments. So you could build your own database servers and make them highly available, or you could use Amazon RDS. We'll talk more about databases as we move forward in this course. But the other thing to keep in mind here is that this public-private subnet architecture is not actually a requirement, but a lot of people like this since it mimics a traditional front-end, back-end architecture like you might have in an on-premises network with a DMZ and internal network subnets. If you wanted to, you could deploy everything into public subnets, but if you follow this pattern, you have a nice architecture that adds a layer of security that protects your critical workloads from being exposed directly to the internet from users on the outside world. So let's talk a little bit more about how the Elastic Load Balancer provides high availability in this model. So kind of zooming in a bit here, we have our Elastic Load Balancer, and then we've got two web servers, one in each availability zone. What we would need to do here is create health checks on the ELB so it can ensure that the servers are healthy before routing any requests over there. So in this example, we've got a basic HTTP health check to ensure that the web server is running. And when it comes to setting up these health checks, you have several options. So you can do basic TCP health checks to make sure that the service is actually up and listening on port 80 or port 443. Or you could create a deep health check that not only ensures that the protocol is up, but also that the server responds with an HTTP 200 OK message. And this is great for those scenarios where you want to make sure that the application is actually serving up content and will be accessible to users. But once those health checks determine that the servers are healthy, we can bring them into service, and then we can start routing requests through the ELB to those healthy instances. Now let's say that sometime later down the road, the health check fails. So the server here at the bottom might go down, or the web server process might crash, and the ELB will figure that out based on the health check. And at that point, the ELB will take the dead server out of service and stop routing connections to it. From there, the ELB will continue to run the health check until the server comes back online, or you can remove the server from the load balancer either manually or through an automated process. And we'll look at that a little bit deeper when we get into auto-scaling. But another thing to mention here is that you can also use Amazon Route 53 in a similar way to do DNS load balancing. Just like the ELB, Route 53 can do health checks just like this, and then only resolve healthy IP addresses to end users. But basically the health check process is very similar. Now let's take a step back and talk a little bit more about the servers in our original example. So again, here's our two availability zones, and each tier of the application is redundant. We've got web servers, app servers, and database servers in each availability zone. And a common approach in this model is to take advantage of elasticity and provide the ability to scale out horizontally on demand. So for our web front-end tier that'll be handling user requests, we can use an auto-scaling group to ensure that we can always meet the demand in those cases where we might get a sudden increase of requests. And of course, we can also do this for our application server tier, which may be a web service or it could be a set of instances that process messages from an SQS queue. But either way, both tiers here are horizontally scalable and they'll expand out and contract based on the demand for the application. And finally, for our database tier, we can take advantage of database mirroring or replication technologies. One database instance can act as the primary node and replicate data to a passive instance, and then we can move the active instance to the other server or fail over automatically in the event of some kind of disaster. But as you can see here, we've got a great solution for high availability. If one of the availability zones becomes unavailable, we still have workloads in every tier of the application running in the alternate availability zone. And since we'd have to handle the entire load for the application with just half of the server capacity, the servers in the web and application tiers can scale out dynamically to accommodate those additional requests, and then the backend database tier can remain online since we have automatic failover in place. Throughout the course, we'll go deeper into these concepts, but for now, let's move on to the module summary and we'll recap some of the important points that we've discussed so far.